In a series of groundbreaking observations, the James Webb Space Telescope, JWST, has revealed an extraordinary phenomenon about 3I Atlas, the interstellar object that has captivated the scientific world since its discovery. This was not just another comet passing through our solar system. The data collected by JWST pointed to something far stranger, far more complex. The implications of these findings are profound, sparking a whirlwind of new questions about the very nature of objects entering our solar system from beyond the stars. 3I Atlas, an object that defied expectations from the moment it was first detected, has proven to be unlike any comet scientists have ever encountered. When JWST turned its attention to it in December 2025, astronomers were expecting to learn more about the composition of the comet, its volatile gases, and the way it interacted with solar radiation. What they did not anticipate was a finding that would stretch the boundaries of current astrophysical understanding, motion and behavior that did not conform to the principles that have governed our understanding of comets for centuries. While scientists have observed comets with irregular behavior before, this was different. What JWST revealed was a pattern of movement that suggested something unusual, something purposeful was at play. The observation, conducted on December 15 to 16 and again on December 27, with JWST's MERI, mid-infrared instrument, painted a picture of 3I Atlas not as a simple icy rock flying through space, but as something far more dynamic. JWST's instruments, designed to capture the faintest traces of light across a wide range of wavelengths, picked up unusual spectroscopic data from the comet, while its signature, cometary emissions, were expected, carbon dioxide being a common outgassing product of cometary activity. What followed was unexpected, evidence of motion that didn't match typical comet behavior. Since its discovery, 3I Atlas has been a subject of intense scrutiny due to its irregularities. From its odd trajectory to the peculiar behavior of its gas jets, the object has presented a series of anomalies that have baffled scientists. Not only was its origin interstellar, a rarity in itself, but it also exhibited several physical properties that do not align with traditional cometary models. In fact, astrophysicist Avi Loeb has compiled and categorized over 18 anomalies associated with 3I Atlas, each one adding a layer of mystery to this already enigmatic visitor. These anomalies raise the possibility that 3I Atlas is not merely a natural object from another star system, but something far more complex and perhaps even engineered. The first of these anomalies was the highly symmetrical pattern of jets emanating from the comet. Unlike typical comets that display random bursts of gas, 3I Atlas emitted jets in a highly symmetrical fashion, with jets appearing at fixed angles to one another. This alignment suggests a precision not typically seen in natural outgassing. Comets generally expel gas from their surface in an erratic, uncoordinated fashion, driven by the varying levels of solar radiation and internal pressures. But in the case of 3I Atlas, the jets appeared to be purposefully positioned. Their symmetry was so striking that it raised an immediate question: could the comet's outgassing be the result of some deliberate design, rather than a natural consequence of heat and pressure? The uniformity with which the jets were expelled hinted at a mechanism far more organized than anything normally associated with cometary activity. This was no longer just a passive object in the vastness of space. It seemed as though 3I Atlas was actively shaping its own behavior. Compounding this mystery was the discovery of an anti-tail, a phenomenon that's never been observed so prominently before. As the comet passed through space, a trail of gas and dust extended in the opposite direction of the sun. This anti-tail, which is a mirrored version of the classic tail that normally points away from the sun, suggested that 3I Atlas was not simply being pushed by solar wind, as typical comets are. In fact, it appeared that some force beyond the usual interaction with the solar wind was at work, exerting influence over the comet's trajectory and behavior. The typical tail we observe from comets is formed when the sun's radiation sublimates the icy surface of the comet, pushing dust and gas away from the nucleus. But with 3I Atlas, the anti-tail suggested that the comet was actively expelling material, possibly using a force generated internally or through some external mechanism, not just by the passive effects of solar radiation. This anomaly called into question what we knew about cometary dynamics, pushing the idea of 3I Atlas being more than just a wandering rock through space. In addition to the primary jets, 3I Atlas displayed multiple smaller jets, each with their own symmetric and angular patterns, further diverging from the expected randomness of natural comet behavior. Typically, comets emit jets of gas and dust in a disordered fashion based on the uneven heating of the comet's surface. However, 3I Atlas presented a more calculated, almost deliberate approach to its emissions. These secondary jets were not only symmetrical, but also angular, with fixed relationships between them, again reinforcing the theory that there might be an external mechanism at play. The precision with which the gas was expelled hinted at a process that went beyond basic sublimation, suggesting that something within or around the comet was regulating this flow. This level of control over gas ejection seemed to defy the natural, random processes we associate with the movement of comets, and brought up the possibility of some kind of engineered influence. The alignment of 3I Atlas's rotation axis was another anomaly that scientists could not ignore. Most comets exhibit erratic and unpredictable rotations, largely driven by the uneven distribution of mass or by the forces applied to them through outgassing. However, 3I Atlas's rotation axis was found to be almost perfectly aligned with the Sun. This is highly unusual for a comet, as most rotate in a chaotic manner, with axes that shift unpredictably as they travel through space. The precise alignment suggested that 3I Atlas might not be subject to the same random processes that influence most comets. Rather than tumbling unpredictably through space, its movements seemed carefully orchestrated, which only added to the growing sense that 3I Atlas could be under some form of external control, or at least some influence that we don't fully understand. One of the more concerning anomalies was the comet's motion. 3I Atlas didn't follow a path that could be solely explained by gravity. Its trajectory deviated from expectations based on gravitational calculations, implying that another force, potentially unknown, was affecting its motion. While comets are typically governed by gravitational interactions with the Sun and other celestial bodies, 3I Atlas's path suggested there might be more to its journey than simple gravitational pulls. Could there be another force at work? One that scientists haven't accounted for yet. The deviation from expected motion pointed to the possibility that 3I Atlas was being influenced by factors other than those currently understood by classical mechanics. This raised the tantalizing prospect that 3I Atlas might not simply be a natural object. Its trajectory could be intentionally altered, perhaps even navigated. Another peculiarity was the velocity of 3I Atlas. The object's speed and trajectory didn't fit the patterns observed in most interstellar objects. Comets typically slow down as they move farther from the Sun, their gas and dust emissions gradually fading as they journey into the outer reaches of the solar system. But 3I Atlas defied this trend. It maintained an unusually consistent velocity, one that didn't seem to match the expected decay based on its distance from the Sun. This could be a key indicator that something other than the Sun's radiation was propelling or affecting the comet. If 3I Atlas's movement was being sustained by an external propulsion source, it would mean the object is not just a comet, but potentially something much more: a probe, an artifact, or some form of engineered object designed to travel across vast distances. When 3I Atlas passed close to Jupiter, its path was altered in a way that couldn't be fully accounted for by the planet's gravitational pull alone. While Jupiter's gravity is strong enough to affect the motion of objects passing through its vicinity, 3I Atlas's deflection was greater than expected, suggesting that another force might have influenced its course. This deflection raised more questions about the true nature of 3I Atlas. If the comet's path could be shifted in ways not accounted for by gravity alone, could this be the result of some kind of purposeful steering? Or is there a hidden mechanism affecting its motion, something we have yet to understand? The outgassing from 3I Atlas showed a delayed onset of methane release compared to typical comets. Methane usually sublimates at much lower temperatures, yet 3I Atlas's methane didn't appear until much later in its journey. This delay raised questions about the internal processes of the comet. Why was methane only released after a specific point in its journey? Was there something unusual about the structure of 3I Atlas that caused this delayed outgassing? Or could it be indicative of a more controlled internal process? Most comets undergo rapid changes in outgassing, with gas emissions fluctuating depending on their proximity to the Sun. However, 3I Atlas's steady, stable release of gas raised further questions. This stable outgassing is inconsistent with what would be expected from a natural body, suggesting that something within the comet may be regulating this process. Could the object be equipped with some kind of internal mechanism that controls the rate and timing of its emissions, or is it simply a product of an unknown natural force? Another issue was the brightness of 3I Atlas. The object appeared to be significantly brighter than expected for a comet of its size and distance from the Sun. This brightness has been linked to a high concentration of reflective materials, further complicating its natural classification. The spectral data of 3I Atlas revealed an unusual chemical signature, especially in terms of its dust composition. Unlike typical comets, which often contain organic material, 3I Atlas displayed an unexpected chemical mixture that didn't quite fit the profile of a natural object from our solar system. The lack of a clear, distinct nucleus further confused scientists. While most comets are characterized by a clear solid core, 3I Atlas showed no distinct nucleus, and its gas and dust were evenly distributed across its surface, suggesting that it might not be a solid object at all. One of the most surprising aspects of 3I Atlas was the absence of a traditional tail, which is usually formed when the sun's radiation vaporizes the comet's icy core. Instead, 3I Atlas displayed a comet-like coma but lacked the expected elongated tail, further confounding expectations. Most comets follow highly elliptical orbits, but 3I Atlas had an orbit that deviated from this pattern. Its path through the solar system was not a simple ellipse but had characteristics of a more complicated orbit, which further adds to the mystery of its origins and behavior. Unlike the typical dust trails that extend behind comets, 3I Atlas exhibited a dust cloud that was more concentrated in front of the object. This forward-facing dust trail raised significant questions about the mechanics of its movement and outgassing. The polarization of light observed around 3I Atlas was different from that of any other comet. The unusual polarization of its light suggests that the comet might have a surface material or structure that is atypical for objects of its kind. The most controversial anomaly is the possibility that 3I Atlas is not a comet at all, but a deliberately engineered object. Some researchers, including Avi Loeb, have posited that the strange motion and outgassing patterns could be indicative of a probe or device sent across the stars. The final anomaly lies in the deviation from typical solar system object behavior. Even as it travels through the solar system, 3I Atlas continues to act in ways that contradict every expectation, suggesting that it's not simply a natural object, it's something that defies the very laws that govern our understanding of interstellar space. These 18 anomalies, as categorized by Loeb, represent a growing list of strange phenomena surrounding 3I Atlas, and they continue to spark heated debate within the scientific community. As new data continues to emerge, the mystery of 3I Atlas deepens, and the question remains, is this truly a natural interstellar object, or is there something more at play here?